Okay, one more hypothesis test here, and we've got some data there. The table shows the weight and volume of parcels delivered by a courier in one day. 1, 2, 3, 4, 5, 6, 7, 8. That's only a sample size of 8, but we want to kind of make a prediction for the entire population from where these parcels came from. Seems pretty obvious that there is a positive correlation. Surely that if you've got more weight, you've got bigger volume, or is it the way around? More volume, bigger weight. So the gut feeling is that, of course, weight and volume should be positively correlated. But let's go and have a look. So before we dive into the hypothesis test, we are going to have a look at the data. It's already there. And I think maybe we just want to have a little look at this to see what the scatter graph looks like. So doc, insert a data and statistics, X and Y. All right, so it looks pretty linear. There's no obvious outliers, and it looks linear. Maybe it's not strong correlation, because if you think about fitting a line on here, the points would be, quite a long way from the line. But remember that the question isn't whether there is any correlation in the sample, but how much we can then say that the correlation exists in the population or it doesn't exist in the population. So this is where we have to do a hypothesis test. So if we go back to here, we are going to put a null hypothesis. So I wonder if I can put a little H0 here. I'll just put an H0 for null. Well, basically, we can either do one of two things. We can do rho equals 0, and rho, the Greek symbol, we could write it in there, is the population correlation coefficient. And now the alternative hypothesis is that sometimes you do a two-tailed test, rho not equal to 0, but the language very clearly states, we can see from the scatter graph that it's kind of positively correlated, so we're testing in one direction for positive correlation. So here we're testing rho is greater than 0. All right. In words, that would be there is no correlation. There is no correlation in the population between weight and volume of parcels. I think that's what the words are. And then the alternate would be there is a positive correlation. And then we would just copy and paste across. You'd have to write that yourself. So there we go. We've got the null, we've got the alternative hypothesis, and we are testing at the 2% level of significance. So let's just go and set our rejection zone. So we would reject the null only if the p-value for our test is less than the 2% significance level. All right. So all we have to do now is just go and do that hypothesis test, and we can go back to our spreadsheet here. And basically, when we are looking at the scatter graph here, and we go back to our table here, we were thinking about linear regression, right? Each time linear regression, and that's where the hypothesis test is hidden. Menu, statistics, stat test, and it's hidden here, look, linreg t-test. So once we go in there, the X list I think we called X, the Y list we called Y. The only thing we have to remember is what's the alternate hypothesis. In this case, it was that rho, the population correlation coefficient, is greater than 0. You've also got a beta here, which is to do with the Y equals mx plus c, but we're interested in this rho is greater than 0. And we press OK. Let's look down at our particular values, and look at that. The p-value is 0.0193. So in here, go back to our answers. We have our p-value for the test equals 0.0193. And if we reject H0 only if the p-value for our test is less than 0.02. So indeed we reject the null. There is significant evidence to suggest there is positive correlation in the population. Boom, there we go, the final hypothesis test. You're welcome.